These are the 1.2 functions notes for Algebra 2. Today we're going to talk about relations, and relation is just a pairing of numbers. So you have a couple different things. You have here the ordered pairs, which you have the x and the y we're familiar with. You have something called a mapping, which is just taking these arrows and going from one number to another and pairing them up that way. So notice here how 4 would be paired with 3. This negative 3 is paired with 4. Same thing over here. 4 is paired with 3. Negative 3 is paired with 4. You also have a table of values. We're used to seeing those. And then lastly, you have a graph. So even though they don't have the numbers on here, you can see that this point right here is 4 over and 3 up. So you can pair them like that. So those are the 4 different ways that people can represent relations, pairs of numbers. The domain is all the x values. In other words, the right to left. And the range is your y values up and down. Okay, so let's look down here. We are going to just list the domain and range. Now, for those of you who are at home, I don't suggest writing out everything you see here. If you just follow along and write down some of the main points, you don't have to write down every example and try to copy every single graph. Just kind of listening and taking it in, and then if you need to, you can come back to this video as you're trying your assignment. Okay, so all it's asking us to do here is list them. So when we list them, we're going to need to go in order from small to large. And then if there are any numbers that repeat, do not repeat them. So these are 2 good things to write down in your notes. And then also the domain and range are 2 great things to write down. Okay, so our first one is in a list of ordered pairs. The first one in each pair is the x. So those are going to be our domains. And we write them down in order from smallest to largest. So the smallest would be negative 8, then negative 3, followed by 1, and then 5. And then for the y's, the range, it's the second number in each pair. Smallest number I see for the y's is 3, followed by 5, 7, and then I see another 7, but there's no need to repeat that 7. So just write the 7 once, and that's fine. All right, the next one, example number 2, is a mapping. What this means is that 3 is paired with negative 3, and 5 is actually paired with negative 5 as well as negative 7. So for our domain, we have our x values here. First are 3 and 5. And then the range are your y values, but make sure you go in order from smallest to largest, so be careful with the negatives. The smallest negative here is going to be your negative 7. All right. Now let's move on to the graphs. The graphs are a little bit trickier. So we're going to set all of our problems up. The domain, and maybe you write this off to the side. The domain is always going to look like this. And the range is always going to look like this. Same thing, but with a y in the middle. And so we're going to want to put our lowest boundary on the left and our highest boundary on the right. So let me explain this through the picture. Domain is our x's left to right. So the smallest x point is here, and the largest x point is here. So low to high. So you can even write left. Erase that for you. You can even write that as left to right. And then the range you could write as low to high. All right, so our domain, the furthest left is 0. Write your symbol less than or equal to. Write your x. and the furthest right is your 4. Now for the y value, you have the lowest y value and the highest y value. So it goes from -4, this point right here, put a y in the center, and it goes all the way up to 5. And that's our domain and our range. Okay, so let's take a look at number 4. Your domain left to right. So that would be from -5, always the same symbols, always an X in the middle for domain. And then your range is going to be the lowest to the highest. Again, lowest to the highest, which would be from -1, always use a Y for that one, to +1. Okay, so here on number 5, notice now we have arrows. That means the graph keeps continuing onward forever. So the domain, if I look, it looks like the domain stops at 3, -3 right here, but the arrow means it's going to keep going, and it's going to keep getting wider and wider and wider. And it's getting wider very slowly, but it's still getting wider. So that means it's going to expand in all directions, right to left, and you have all real numbers. This graph is going to go everywhere. So when that happens, you're going to write something like this. Now, it's just an R with a double stick. You'll notice sometimes it's filled in like that. That's great. Or you can leave it just as the R with a double stick. All right, so for the range, there is a low boundary. Your graph never goes lower than that. So we can say the low range is -3. And then the high range, if you notice, these arrows keep going in both directions. So there is no high range. It just keeps going. So it goes on forever. So I just leave it like that. You might also see this written as the opposite direction. Flip the Y to the front, flip the sign to go the other way, and flip the -3 to the end. These are both the same. So sometimes you'll see people write the Y first. All right, let's try another one of those. We've got our domain. We've got our domain, which is going to be from 1, write it over here, from 1 all the way until, and then I think, okay, well, where is this going to stop? Well, I don't think it's going to stop because notice my arrows keep going. So they'll just go on forever, no matter how big the numbers get. And remember, you could also write it like this. Flip it around. Write your X first, flip the sign, and make it 1. All right, let's talk about our range. The range, again, it's going lower and lower and lower the wider it gets. Same thing up here. It's just getting wider and wider and wider. It's going really slowly getting wide, but it is still getting wider. So for the range, we're going to say all real numbers because there's never going to be a place where we could say, okay, it's never going to go past that line. Because if you go out far enough, it will eventually get fat enough that it crosses through that line. All right, and the last one. Domain, left to right. Let's see, my V shape keeps getting wider and wider, so I don't think there's ever going to be boundaries on the left or the right that I can draw. So that's going to be all real numbers. Again, you can write that and fill it in if you want, or just leave it as an R with a double stick. For the range, the range does have a low point. It never goes past -2. But then notice the arrows here, keeps going up forever, so it goes on forever. So remember, we could write it like that, or flip it, and flip it. Okay, so let's move on here. The next thing we're going to talk about is functions. Functions are a special type of relation where for each input there is only one output. So I always say it like this. This guy's kind of in the wrong space, so I'll get rid of him. I always say that the X's can't cheat. X's can't cheat. Write that down. So what I mean by this is a relation is just a pair of numbers, kind of like a relationship is a pair of people. And the X's are one person in the relationship and the Y is the other. And if the X is supposed to be dating Y, it shouldn't be dating anybody else. Let's look at example number 1. 2 is all coupled up with 1. They're a happy little couple, right? Everything's good. But then look at 8 down here. 8 is seeing 3 on the weekends and then seeing 5 during the week. That is not okay. This is the X value and X's are not allowed to cheat. And right now, X, the 8, is cheating. It's paired up with 3 and it's paired up with 5. So we say, is that a functioning relationship? Well, no, because the X is cheating. All right, take a look at number 2. 1 is paired with 6, they're happy. 2 is paired with 5, they're happy. 3 is paired with 7. So is that a function? Yes. All right, problem number 3. I want you guys to just take a look at it and make your best guess. Your answer is either just going to be yes or no. Number 3 is a no because of this -3. So -3 is paired with 11 one day, and then you turn around and -3 is paired with 8. It's cheating. Take a look at number 4. Is that a yes or a no? Number 4 is a yes. Each of them are paired with just one number, and none of the X's are cheating. All right, number 5 is a little bit strange. It's a special case. 3 is paired with 1, 4 is paired with 1, 5 is paired with 2. So remember our rule that the X's can't cheat. So oftentimes people will say, oh, look, the 1 is cheating, right? Yes, but the 1 is a Y. And mathematically, the Y's are allowed to cheat. The X's can't be cheating. Okay? So this is still a yes. And the reason that works mathematically, not actually in the dating world, but the reason it works mathematically is, let's say you're doing problems and you do problem number 3 and you get an answer of 1. Then you do problem number 4 and you happen to also get an answer of 1. Just because you got an answer of 1 twice doesn't mean that you did one of those problems wrong. However, if you go back to problem number 1, if you look at 8 right here, right? If you look at 8, if you did problem number 8 and you got an answer of 3, and then you did problem number 8 again and you got an answer of 5, something is wrong. That's not okay. That's not allowed to happen. You should be getting the same number every time you do problem number 8. So that's kind of why mathematically the X's can't cheat, but the Y's can. They are allowed to cheat. Okay, so we have a few more problems here. Take a second and maybe just on a scrap piece of paper or in your mind, just think about the answers for 6 through 10. X's can't cheat and decide whether it's yes, a function, or no, it's not. I'll give you about 20 seconds. For number 6, it's a no. Here's the reason why. 8 is paired with -7, 8 is paired with +7. Once the 8 pairs up with somebody, it must pair up with that same number every time. Number 7 is a yes. Number 8 is a no. Again, notice that right here, the -1. 10 is a yes. The Y's are cheating, but that is okay. X's are the ones that can't cheat. So even though the 4s and the 7s repeat, that's okay. The X's are not repeating with different numbers. Number 10 is a no. 3 is paired up with 2. Therefore, 3 should not be also paired up with 8. So if you're taking any notes, make sure you jot down that the X's can't cheat, but the y's are allowed to cheat. All right, last part that we're going to do here is our graphs. And then we've got this little piece at the bottom. All right, so for number 11 through 14, the way we're going to check these, because we don't have any numbers to see whether they're repeating, we're going to do something called the vertical line test. Write that down. Vertical line test. And vertical is up and down. Vertical is up and down. Vertical line test. So, if your vertical line, we're going to draw a vertical line anywhere you want through the graph. And if the vertical line touches the graph more than once, it's cheating, and therefore, no, it's not a function. So if there's anywhere that you can draw a vertical line straight up and down, and your vertical line touches the graph more than once, it's cheating, it's a no. So on example number 11, I'm going to draw my line right here. Well, it touches once and twice. So that's a no. For number 12, it doesn't matter where I draw my line. Here, it only crosses once. Over here, on the right-hand side, it only crosses once. So the vertical line has to cross 2 or more times. So no matter where I put it here, it's only crossing once. This is a yes. Number 13, anywhere where you draw this, it's going to cross through. So you cross this through once, twice, and 3 times. That one's cheating on 3 different people. That is a definite no. What do you think about 14? Do you think that's a yes or a no? Number 14 is going to be a yes. If I draw my line vertically, it only crosses the graph 1 time. All right, so number 15 at the bottom is kind of just to fill in on your own. You can fill in any numbers that you want. Your only stipulation is that you make this into something that is a function. So just make sure that none of your x's are cheating. But then over here, you want to make sure that this is not a function. So what would we need to put in to make sure that this is a function? Just make sure the x's can't cheat. So you can put in any numbers here that you want. Maybe I'll put in a 5 right here, paired with 2. 15, I'll pair it with a 20. Maybe a 7, I'll pair with a 6. And that looks like a 1 down there. Maybe I'll pair that with a 3. Now, if I look at all my x's, I'll notice that none of them are cheating. On the table that you need to make that is not a function, what would we need to put in here so that way one of our x's is cheating? How would you do it? How would you fill in this table? Maybe you decided to put 15 up here and then pair it with a different number like 7. Now 15 is cheating. Maybe you decided to make this into a 2. And then you decided to make, let's see, not a 2, that's not going to work. Maybe you decided to make that a 1 and a 6 and a 1 and a 10, right? So there's a couple different ways you can make that not a function. It's completely up to you, but just notice here you've got your x's that are cheating. Here all of your x's are behaving. Okay, so we'll practice that more, but if you have any questions, jot them down and we'll go through them together in class. Great job today.